I'm Christina from Soundwaters, and I want to welcome you to our virtual field trip, part of our series on climate change. Before I introduce my colleague Jess, who will be leading you through this virtual field trip, I want to make sure you have viewed our video on greenhouse gases. Understanding greenhouse gases and how they influence climate change is an important prerequisite to the subjects in this series. So I encourage you to pause now, view greenhouse gases, and come back to learn more from this video. I'm sure you will enjoy learning all about climate change, how it affects our environment, and things you can do to mitigate the damaging effects. So, without further ado, I would like to introduce my colleague and friend, Jess.
Sea levels around the world have been rising at an increasing rate. In the United States, 40% of the population lives very close to the shore. These coastal areas are susceptible to the hazards associated with rising sea level, such as coastal erosion, flooding, and storm hazards. Sea level is defined as the average level of the sea after taking out daily fluctuations and local fluctuations. So these local fluctuations are usually due to waves or to wind. Throughout Earth's history, the global sea level has fluctuated as well. And sea level rise is an increase in the average sea level around the globe. According to NASA, sea level is rising 3.3 millimeters every year, and that's about 3 credit cards stacked on top of each other. This increase might not seem like much, but it leads to more storm surge pushing inland. It also has been increasing the frequency of nuisance flooding or sunny day flooding. And this type of flooding happens during an excessive high tide. And what happens is the water comes up too high, and a lot of times it causes road closures and human inconveniences. In the last 20 years, the frequency of this has increased 50%. And in the last 30 years, it's increased 100%. The two main causes of sea level rise are the thermal expansion of the ocean and melting land ice. As humans have burned fossil fuels, they emit carbon dioxide into the atmosphere. This carbon dioxide, along with other greenhouse gases, is trapping a lot of heat near the surface of the Earth and heating up the atmosphere. The ocean absorbs 90% of the heat out of the atmosphere, so it's not only warming the atmosphere, but it's also warming the ocean. Glaciers exist on land all year long. They can be found in the mountains of every continent except for Australia. Greenland and Antarctica are covered in giant ice sheets. As the atmosphere starts to warm, these glaciers and land ice will start to melt. And as they melt, they're adding water into the ocean, which is increasing the sea level. Now, there are also sea ice formation in the Arctic and Antarctic, and there's also icebergs that float around. As those icebergs and sea ice start to melt, do they contribute to sea level rise as well? We're going to do a little simulation to see just that. I have 2 flasks here representing 2 different simulations. This is our iceberg and sea ice in the Arctic and Antarctic. So this container has 3 ice cubes in the water already, and this container has 3 ice cubes in a cup above with the same water level as our iceberg simulation. So this is representing the glaciers and the land ice found in Antarctica and Greenland. And both of these containers started at 150 milliliters, so the same level, the same height. We're going to leave them for a little while and see what happens as all of our ice starts to melt. Our setup has been sitting for a few minutes now, and if we take a look, we can see that the ice in our iceberg simulation has almost completely melted into the ocean. And in doing so, it did not change the volume of the water in this simulation at all. It's still at 150 milliliters. And this is all due to something called Archimedes' principle of buoyancy. So the mass of the ice is equal to the mass of the water that's being displaced by that ice. So as the ice melts, it's not changing the volume of the water at all. It's changing the density, but it's not changing anything else. So there's no change in the amount of water in the ocean as the icebergs or floating sea ice melts. Now, if we look at our other simulation, which is the Greenland and Antarctic ice sheets, we can see as they are melting, they're introducing new water into the ocean. And by introducing that new water that was not there before, they are increasing the volume. So this one has gone from 150 to about 175 milliliters. So as the ice sheets in Antarctica and Greenland continue to melt, they will continue to rise the sea level around the world. Scientists have been monitoring the changes in these ice sheets for a few years now, thanks to the use of satellites. There are 2 satellite missions NASA has been utilizing to monitor the ice sheets of Antarctica and Greenland. The Gravity Recovery and Climate Experiment began in 2002 with the launch of the first satellite, and the follow-on was launched in 2018. And this satellite mission has seen a decline in the mass of both the Greenland ice sheets as well as the Antarctic ice sheets. This decline is staggering to see. In a new study published in April of 2020, researchers found the loss of this land ice accounted for 0.55 inches of sea level rise to the global ocean since 2003. This data comes from the Ice Cloud and Land Elevation Satellite 2, or ICESat-2, which was launched in fall 2018. It takes detailed global elevation measurements using lasers. By comparing this data to that collected by ICESat from 2003 to 2009, there is a 16-year span of data to draw conclusions on. And this study found that Greenland's ice sheets lost an average of 200 gigatons of ice per year, while Antarctica lost an average of 118 gigatons of ice per year. 1 gigaton of ice is enough to fill 400,000 Olympic-sized swimming pools. And this contribution of freshwater to the poles has the potential to severely impact ocean circulation and sea level. In addition to land ice melting, the thermal expansion of the ocean is playing a role in sea level rise. We've mentioned that the ocean is absorbing a lot of the energy from the sun. Absorbing this excess energy is raising the temperature of the ocean. By raising the temperature of the ocean, sea ice is not the only thing being affected. It's also causing the water to expand. So thermal expansion is what happens when the water warms. The extra energy that's coming into the ocean is allowing all of the hydrogen bonds between the water molecules to form and break very quickly. And by that, it's increasing the volume of the ocean. So warm seawater has a greater volume than cold seawater. So as the ocean temperatures continue to warm, it will continue to take up more space, increasing sea levels around the world. To better visualize this, we're going to do a little experiment. So this is our experimental setup. We have a flask full of blue water that's representing our ocean. And I have a pitcher full of hot water here. So I'm going to pour the hot water in around the outside of our ocean, and it's going to transfer its energy to the water in the ocean, making it warmer. And we'll see what happens to the level of the ocean. So right now we can see barely the water right here. So that is our starting line. We're going to leave this for a few minutes and see what happens. After sitting for just a few minutes, the level of our ocean increased significantly. So we started down here at 0 milliliters, and right now we're actually off the scale. See, very high. So the water has been increasing because the hot water around the outside of our ocean has been transferring its energy to the water in the ocean, and that's making it take up more volume as it's gotten warmer. And this is happening not only in the ocean, but also right in our backyard in Long Island Sound.
The interesting thing about the sea levels around the world is they're not all changing the same way. In some areas, the rate might be different than in others. One example is actually here in Connecticut. The land is moving. Here we have something called subsidence, and this is when the land starts to sink. A lot of times it's due to removal of things from underneath the land, such as water, natural gas, or different resources like that. Now across the country in California, the opposite is happening, and the land is actually rising due to tectonic plate activities. And down in Louisiana, their landmass is sinking as well, but for a little bit of a different reason. There's a lot of deposition of sediments from the Mississippi River in Louisiana, which is weighing down the landmass. Currents play a role in sea level as well. In the Atlantic, one of our major currents is the Gulf Stream. It starts in the Gulf of Mexico, goes along the east coast of the US, and ends up in the Arctic. In the Arctic, it gets very cold and its density gets higher, so it gets heavier and it sinks down to the deep ocean. Now, with the melting glaciers off of Greenland, the water is getting less dense because of the addition of the fresh water, and this is slowing the rate of the sinking in the Arctic. Now, the Gulf Stream is still going full steam ahead, and what happens is the water actually piles up along the east coast of the United States, affecting its sea level.
Gravity can impact sea levels around the world as well. In this animation created from data collected by NASA's GRACE satellite, we can see patterns of rising and falling sea levels across the globe. This pattern is in response to changes in Earth's gravitational and rotational fields. Major changes in water mass can cause localized bumps and dips in gravity. For example, the melting glaciers on Greenland actually cause a nearby sea level to drop. As they lose mass, the gravitational pull of the glacier lessens, and seawater migrates away. You can see this clearly in the animation of the data from NASA. There is a significant decrease in the sea level around Greenland. You can tell by that really deep red color. But near the coastlines further away, the added water causes sea levels to rise, turning it a deeper blue.
Now that we understand what sea level rise is and how it is different in different parts of the country and different parts of the world, we're going to focus on the Long Island Sound. According to NOAA, the Long Island Sound has risen 10 to 11 inches in the last century, and projections for the global ocean are another 1 to 4 feet rise by 2100. Now, if we were to compare that to this building, this here is the high tide line right now. If I were to add 1 foot to this line, would be here, not quite all the way up to the building yet. 2 feet here, 3 feet to here, and then 4 feet, be much further, all the way up to the middle of this building. Now, there are some tools that scientists have been developing to help planners know what the risks in different communities are. Climate Central is an organization that has built a coastal risk map to help people in local coastal communities understand what risks they have for sea level rise.
If we take a look at the coastal risk screening tool Climate Central has developed, we can get an idea of future sea level locally. Right now, I have my settings to show just sea level rise under moderate cuts to the amount of pollution being emitted into the atmosphere. So that assumes that carbon emissions are under control. If we take a look at Cove Island Park in Stamford, it's where the Soundwaters Coastal Education Center is. The water is encroaching on the Soundwaters building, but the rest of the park appears to be fairly safe. Now, if we zoom out the map and we take a look at Western Stamford, it's a bit different. The South End and Harbor Point can be inundated with water. Another really cool thing is we can change the settings on here. So I can add in the annual flood, which is the height of a local flood, and that's only usually exceeded once per year. Now if we take a look, Cove Island Park has a lot more water, a lot more flooding, and the South End and Harbor Point do as well. And the water is also encroaching on I-95 and the train tracks. Take a look at this website in your local area and see how sea level rise might affect you.
What are some other ways sea level can have an impact on coastal communities? We've already mentioned that flooding will be the new norm, and this flooding is going to have major impacts on human populations, such as infrastructure damage, damage to buildings, and impaired travel.
As climate change, including sea level rise and extreme storms, threatens Connecticut's shoreline, more and more questions are being asked about the wisdom of keeping portions of the main rail line where it's been for more than 100 years, right along the coast. The Amtrak Shoreline East Line runs along the shoreline in the Niantic section of East Lyme, more or less where it's been for more than a century, and where it was when the hurricane of 1938 damaged stretches of track. Superstorm Sandy also damaged the track in this area. It washed out the boulders fortifying the embankment supporting the rail line in Niantic and separating it from Long Island Sound on the right. Such questions have also come up in Bridgeport and New Haven, where key stations and rail yards were built on fill-in areas that were once Long Island Sound. In Bridgeport, the tracks are elevated and designed to sit above the water. There are some stretches, however, of the line that are at ground level in salt marshes and flood zones. That can be seen here. This is a view from a Metro-North train. It shows the salt marsh that runs for miles along the train corridor from the Saugatuck River nearly to Fairfield. Roadways are also threatened by sea level rise along the coast. In a recent study published in the journal Transportation Research Record, researchers found that tidal nuisance flooding threatens over 7,500 miles of roadways along the entire East Coast, with over 400 miles of that being interstate roads. They estimate that this causes over 100 million hours of delays each year for drivers on those roads, and that number could rise to more than 3.4 billion hours by 2100. By 2060, they predict nuisance flooding could occur almost daily at certain sites along the shores of Connecticut. Flooding and road damage may also occur further inland than previously thought due to rising groundwater from sea level rise. Researchers at the University of New Hampshire Center for Infrastructure Resilience to Climate found groundwater impacts occur more than 2 times further inland than surface water flooding, potentially impacting many more miles of roadway. This sea level rise induced groundwater rise can flood roads in locations where the groundwater levels are already high, such as near wetlands, estuaries, or even rivers. Even if flooding doesn't occur, the groundwater can rise into pavement base layers. If the sand and gravel beneath the pavement becomes saturated, then the strength that's relied on to carry traffic is not there anymore, so the pavement develops ruts and cracks, allowing more water to get into the underlying layers, and making the situation even worse. Closing roads for long periods of time for repairs impacts both commuters and tourists. Superstorm Sandy that we mentioned earlier severely impacted the East Coast, especially the communities of New York, New Jersey, and Connecticut. Hurricane Sandy was the perfect storm. Its impact with the East Coast coincided with not only high tide, but high tide of the full moon. Full moons cause some of the highest tides of the month. Couple that with 90-mile-per-hour winds, and you have yourself a superstorm. Together, the tide and wind caused a 14-foot storm surge in New York Harbor. In Fairfield, Connecticut, there were 1,000 homes damaged due to flooding, and 6 homes completely washed out into Long Island Sound. Bridgeport Airport became inundated with water, flooding the area and jeopardizing planes. Sand buried main roads and dispersed up to half a mile from the water. This photo was taken in Old Lyme, Connecticut, and shows trucks clearing a road to make it passable for residents. Now imagine the storm happening today, 8 years later, with increased sea levels.
Now we understand the effect that sea level rise can have on the human population. Let's focus on the population of Long Island Sound and the habitats they rely on. This behind me is a salt marsh. The salt marsh lies at the intersection of Long Island Sound and the land, and it's used to being inundated with brackish water from Long Island Sound during high tide, and then have periods of drying out when the tide goes back out. Sea level rise will cause these areas to pretty much drown. It will convert the low marsh into an intertidal mudflat and the high marsh into a low marsh. All of these areas are habited by distinctly different plant species. The ones in the high marsh are not used to being inundated with water as frequently, so they will change. And this will have a dramatic effect on the animals that rely on this area. Salt marshes are able to grow. Sometimes they can grow vertically by accruing new sediments, and they can do this as the sea level rises. It's just that the rate of sea level rise is too fast for salt marshes to keep up. So what they try to do instead is move horizontally, and they try to move up onto the land. In Cove Island Park, where we are now, they are able to do this. There is some room. This is not the case everywhere. In a lot of locations, salt marshes are right up against buildings or against sidewalks, and there's nowhere for them to go. And this is when the drowning comes into effect, and these salt marshes start to die. Scientists are just starting to try to understand what will happen if we lose these salt marshes. They are so ecologically important to the ecosystems and to humans. They provide habitat for a number of organisms, both juvenile and adults. They also help to prevent erosion in the areas behind them and provide stormwater protection for us. Animals that live in Long Island Sound will be affected by sea level as well, especially the ones that rely on the salt marsh as their habitat, such as mussels, fiddler crabs, and diamondback terrapin. Mussels, as you can see here, live in the sediment of the salt marsh. They're filter feeders, so they open up to breathe and take in water during high tide, and they close again during low tide. If their habitat is eroded away, there will be nowhere for them to attach, so they won't be able to survive. Fiddler crabs, on the other hand, dig burrows in salt marsh sediment, So they make tubes down into the sediment, which they use for mating, reproduction, hibernation, and to hide from predators. So they come out during the daytime and during low tide, and they do what they have to do, find their food and all that, and then they go back into their burrow during high tide and at night, and they stop up the whole of the burrow with sand or mud. And they breathe oxygen from the atmosphere. So if the level of the water is constantly above their burrow, they won't be able to come out, and there could be severe repercussions on their populations. Diamondback terrapin are another native Long Island Sound species that can be affected by sea level rise. They use the salt marsh as a foraging ground and as protection, as well as the adjacent beaches for nesting. With sea level rise and changes to coastal habitats, there could be effects on the diamondback terrapin population. They have high nest fidelity, which means that they come back to the same place year after year to make their nest and to lay their eggs. Any changes to the coastal habitat due to sea level rise could impact their reproductive success and the population for years to come. Sea level is important in understanding how climate change is affecting not only our coast in Connecticut, but coasts all around the world.